In the world of scientific discovery, some innovations fundamentally change how we understand the molecular building blocks of life. John Bennett Fenn was one such innovator, a chemist whose groundbreaking work transformed the field of mass spectrometry and opened new frontiers in biological research. Born in 1917 in New York City, Fenn's journey into science was marked by curiosity and persistence. He earned his doctorate in chemistry from Yale University and spent decades working in both industry and academia. But it was later in his career, when many scientists might consider slowing down, that Fenn made his most revolutionary contribution. Mass spectrometry is a technique that allows scientists to identify and analyze molecules by measuring their mass. Think of it as a sophisticated scale that can weigh individual molecules with incredible precision. For decades, this technology worked well for small, stable molecules, but there was a significant limitation. Large, fragile biological molecules like proteins would break apart during the analysis process, making them nearly impossible to study. Fenn recognized this challenge and devoted himself to solving it. In the 1980s, he developed a technique called electrospray ionization. The process works by gently converting large molecules dissolved in liquid into a fine mist of charged droplets. As the solvent evaporates, the molecules are left behind as intact, charged particles that can be analyzed without being destroyed. The elegance of electrospray ionization lies in its gentleness. Unlike previous methods that used harsh conditions, this technique treats delicate biological molecules with care, preserving their structure while making them accessible to mass spectrometry. It was like finding a way to weigh a butterfly without damaging its wings. The impact of this innovation rippled across multiple scientific disciplines. Suddenly, researchers could analyze proteins, peptides, and other large biomolecules with unprecedented accuracy. Pharmaceutical companies could better understand how drugs interact with their targets. Medical researchers gained new tools for diagnosing diseases and understanding biological processes at the molecular level. Fenn's work democratized mass spectrometry, making it accessible and useful for studying the complex molecules that drive life itself. His technique became a cornerstone of proteomics, the study of all proteins in an organism, and remains essential in modern biochemistry and medicine. In 2002, at the age of 85, John Fenn received the Nobel Prize in Chemistry for his development of electrospray ionization. Sharing the honor with Koichi Tanaka and Kurt Wuthrich, Fenn's recognition came remarkably late in his career, proving that scientific innovation knows no age limit. Even after receiving the Nobel Prize, Fenn continued working in his laboratory, driven by the same curiosity that had fueled his entire career. He remained active in research until his death in 2010, embodying the spirit of lifelong learning and discovery. John Bennett Fenn's legacy extends far beyond a single technique. He demonstrated that persistence, creativity, and a willingness to tackle difficult problems can lead to transformations that benefit all of humanity. His electrospray ionization method continues to advance our understanding of biology and medicine, touching countless lives through improved diagnostics and drug development. In the story of modern science, Fenn stands as a reminder that innovation can emerge at any stage of life, and that the pursuit of knowledge is a journey without end.